Welcome to Chapter 7, Double Displacement. We could look at mixing two reactants together, and we need to decide, did a reaction happen? We look for four things, and sometimes they're called forces. We say it drives a reaction. Another way to say it is it moves forward or produces products. And those four forces are formation of a solid, as we know, a precipitate, formation of water, the transfer of electrons, or the formation of a gas. So if you mix two chemicals together and one of those things happen, we say that the reaction happened or went forward. We can look at the different types of reactions, and that is going to let us to figure out what the products are going to be. So much of the rest of the chapter will be looking at the reactants, deciding what type of reaction it is, and then predicting the products. We're going to start off with double replacement. It is also called double displacement or double dis. Now there are two types, precipitation reactions that we're familiar with and acid-base. We'll start off with the precipitation reactions. Precipitation is forming a precipitate, taking two aqueous or soluble ion components, mixing them and forming some sort of a solid, a precipitate. What happens is the metals replace a metal and the nonmetal can replace the nonmetal. We're in aqueous solutions, which means the reactants are always aqueous and the driving force is the formation of a solid. Some examples of precipitation reactions are clamshells. That's the precipitation of calcium carbonate. Hard water contains magnesium and calcium ions, and laundry detergents include sodium carbonate, which reacts with those dissolved ions and forms precipitates, and it takes it out of the solution for us. Let's take a look at how this happens. In our example, we have two aqueous reactants, potassium iodide and silver nitrate. Notice because they're aqueous, they've been dissociated. They're not touching each other. We mix them together, and we have potassium nitrate and silver iodide. Silver iodide, we know, is soluble. We've taken the metal and combined it with the other anion, and we've taken this metal and combined it here. A good way to think about it is foiling. We're doing the first and last ions and then the inside ions. So in this case, we have sodium nitrate, and so we write the formula for sodium nitrate. Then we have silver chloride, and we write the formula for silver chloride. In this reaction, we have potassium nitrate, so we write the formula for potassium nitrate. And by the way, we write the product formulas by crossing, just like we were writing formulas earlier in the chapter. And then we have barium sulfate, and that becomes one of our products. Here's another example. We have, again, potassium iodide, and this time it's lead nitrate. So before we mix them, they're separate. Once you mix them, they start bumping into each other and reacting, and eventually you get the lead iodide solid, so it's at the bottom, and then the potassium nitrate, because it's soluble, it's ionizing. Let's take a look at the animation. We have our individual aqueous solutions. We dump them in. At the molecular level, we can see all of the ions floating around. We have our nitrate, our potassium, our lead, and our iodide. So we see that the lead iodide is dropping to the bottom, but the potassium and the nitrate are still aqueous. We have our lead iodide at the bottom, this nice yellow color. So here's a listing of what we want to do. We want to look at the ions, and then we're going to swap them. We're going to write the new formulas for each product, and we may have to write the formulas of the reactants. We're going to balance the equation, and then we're going to use our solubility rules to figure out the product's state. Is it going to be aqueous or is it a solid? Pause the video and write the formulas of the reactants, potassium phosphate and magnesium chloride. Now that we have our reactants written, we need to write the formulas for our products. So we are going to be taking potassium and chloride and writing a formula for that. And then we'll also take magnesium and phosphate and write a formula for that. Now we need to balance. Notice that we didn't care about the subscript 3 for this potassium or the 2 for the chloride. We just took those ions because they're floating around separately and crossed them to get our new formulas. But that means in order to obey the law of conservation of mass, we have to balance it. For example, we know this is unbalanced because there are 3 potassium in the reactant side and only 1 in the products. So pause the video and balance the equation. Now that it's balanced, we want to find out what the solubility is or the state of our products. We have potassium chloride. If we look, potassium is a group 1, and so that is going to be soluble. If we look at a phosphate, magnesium phosphate, those are generally insoluble, and magnesium is not one of the exceptions, so that's going to be a solid. We're going to go through 4 steps for our next couple of examples. We're going to write the formulas for our reactants, the formulas for our products. We're going to balance the equation. And lastly, we're going to put in the states for our products using our solubility rules. We have magnesium acetate, and it's reacting with sodium phosphate. So the magnesium is going to be with the phosphate, and the sodium is going to be with the acetate. So first of all, we have the same formulas, so we know the formulas are correct, and we need to look at the states. So magnesium phosphate, well, we know phosphates are going to be solids. That means we can eliminate anything that has magnesium phosphate that's aqueous. We can eliminate A and C. Now we need to look at sodium acetate. Well, sodium is a group 1, so it has to be soluble. That means it's going to be aqueous, and we can eliminate D and have B as our answer. We are reacting silver nitrate and potassium carbonate, so we're going to have silver carbonate and potassium nitrate. If I look at my first answer, it has 2 cations. I have silver and potassium, so that cannot create a compound. Potassium carbonate is one of my reactants, so I'm going to eliminate those 2. Even though it has different states, it's still part of the reactants. I have silver carbonate or potassium nitrate. C is nitrate carbonate, 2 anions, so those aren't going to form a compound. And I have potassium nitrate. Potassium nitrate is one of my possible products. Potassium is group 1, and nitrate is also soluble. D is the correct answer. Pause the video and go through the 4 steps for this reaction. So if I want to write magnesium nitrate, I cross and get my formula. I know it's aqueous because it's a reactant. I cross calcium with sulfide, get the formula, also aqueous. Now I want to write the formulas of my products. So pause the video, cross magnesium with sulfide, calcium with nitrate. Next, I need to balance. So I have magnesium, 1 magnesium, 1 magnesium, 2 nitrates, and 1 calcium. So this equation is balanced as written. The last step is to figure out the states or the phases for my products. I have magnesium sulfide, and I know that sulfide is insoluble, so that's going to be a solid. I have a nitrate, which is soluble, and there's no exceptions, so that's going to be aqueous. Pause the video and go through the 4 steps for this equation. I've written the formulas, crossing sodium with nitrate and calcium with sulfide, and now I need to figure out what my products are going to be. So I'm going to cross sodium with sulfide and calcium with nitrate. So now I have my products, and I need to balance my equation. So working through, I see I have 2 sodiums on this side and only 1, so I'm going to have to put a 2 in front of there. That will give me 2 nitrates. The calcium's okay, and the sulfide's okay. My last step is to look at my products and decide what state they're in. I know that nitrates are soluble, so that is going to be aqueous. I also know that sodium is group 1, and so that's going to be soluble. Once I put my states in, I see that I have 2 aqueous products. And so really, even though I can write this, and you should if you're asked to, this is not a reaction because I don't have the driving force of the precipitate being formed. Let's try one more. You need to write the reactants formulas, so cross sodium with chloride and silver with nitrate. Now that I have my reactants formulas, I want to figure out my products. I'm going to cross sodium with nitrate and then silver with chloride. Looking to balance this one, I notice that it's balanced as written. I don't need to add any coefficients. If I look at sodium nitrate, group 1 plus a nitrate, definitely going to be aqueous. I have silver chloride. Most chlorides are soluble, but silver is an exception to that, and it will be a solid.